Okay, so one thing I just noticed here when I open up Unity, and this happens somewhat often, it says there's a new version of Unity available, blah, blah, blah. Unless there's a major revision just to keep things compatible, I would probably say skip new version. This would probably not be a problem if you happen to have already downloaded it or something like that. I doubt there's going to be an issue. Let's see, it's current installed version is 2018.2.5 F1, and they want to go to 2018.2.8. So typically when that very last number is the only one that changes, it's a very minor revision. When the middle number changes, that's still a fairly minor but a little bit bigger revision. If the first number changes, you probably want to update because that's a major release. Okay, so I'm going to just say skip new version for now. Okay, and if you remember from last time, I think it's here at the very end, we had our dude kind of going back and forth here, but he was doing some rolling. And then he can also get, the pumpkin can interact with him. Okay, so we have let me open up the scripts that we have for this guy. So I go to project, go to assets, we'll go to scripts, and we have golem movement. So I'll double click on that. Okay, so here's our golem movement. We went ahead and grabbed the rigid body. So we had these two private variables up here. We have the rigid body, which we set here in awake. Remember that the default script has a function here called start. Awake actually happens before start happens. So start is once the script is running. Awake is when the script kind of like when it's first double clicked on to start running, but it hasn't started running yet. So inside of this awake function, and if you've had Android programming, this stuff is kind of similar to the Android activity lifecycle, where there's different points in time where you can kind of interject some logic into your Android app, like when the activity first is created, when the activity comes back from the background and it starts running again, things like that. You have different points in times you can interject some logic. All right, so on awake, and this happens exactly one time. Well, it happens exactly one time per game object that this script is attached to. All right, so I want to make sure we're clear here that when we drop this script onto our actual golem in our screen, he owned a copy of this script. We could have another dude, we could have that pumpkin have a copy of this script as well, and we can then move the pumpkin. And I'll just show you that real quick. So I'll click on our pumpkin. This guy does have a rigid body, so that won't break. I'll go ahead and add the component, because if he didn't have a rigid body, when I went to try to grab the rigid body associated with that guy, it would fail. It would say this component doesn't exist. All right, so I'm going to add a component here. I can just drag it over if I want. I can say golem movement, drag it on there. So now there's actually two different game objects in our scene that both have the same script running on it. And if I hit play here, or if I hit play better, you see how the pumpkin moves as well? So two copies of that screen are in existence here. They're completely independent of each other. So the awake function of each of those was called once. And now the update method on each of those is getting called as I'm dragging these guys back and forth. But you're seeing that I'm actually controlling two different game objects with the same back and forth. If I'm going to use the same buttons, I'm going to have some issues for, like I could maybe change the controls so I can control the pumpkin with the WASD keys or something like that, or at least maybe the A and D keys for back and forth. I can control the golem with the arrow keys. Therefore, I can actually run them independent of each other, but you kind of get the point. I can have that script attached to multiple things, and each one's its own copy. Okay. Let me go ahead and remove that from the pumpkin here. So I'll just remove that component. And again, remember, game objects are collections of components. And what makes something a game object? How can we tell when we see a game object in the wild? If I look at its component list, what component's always there for a game object? Transform, this dude up here. So game objects have a place in 3D space that have a rotation and a scale associated with them as well. All right, so we'll go back in here. So I grab the rigid body. Inside of update, we're going to go ahead and update. It's called once per frame. So for faster graphics cards, this will get called more often. For slower graphics cards, it'll get called less often. There is an alternate version of this called fixed update that tries to mimic it to 60 frames per second. But what we'll do here is we'll grab the horizontal axis, which is our left and right arrow keys. And this is just going to give us a value between -1 and 1 for where we are on the horizontal axis. And then what we're going to do is, and this was right at the very end, I just got it working, so we're going to start talking about vector 3s here in a second. We're going to set the velocity of that rigid body. So the rigid body's velocity equal to this new vector 3. So let me open up our slide set here. All right, so we have this thing called a vector 3. All right, now what's a vector 3? It's a fancy name for a transform. Okay, actually, it's even more simplified than that. It's a fancy name for one of the components of a transform. For instance, we have a vector 3 that governs the position. We have a vector 3 that governs the rotation. We have a vector 3 that governs the scale. So vector 3s are the underlying data structure is called a struct from C and C++, but it's a variable that can hold an X, Y, and Z coordinate. That's it. That's what a vector 3 is. It can hold 3 values. Okay. So holds an X, Y, Z collection of values. That's it. So it's a little bit of a scary name for something that doesn't do any more than just hold 3 things. Typically, we're applying it to either the position on the screen or the rotation of a game object or the scale of a game object. Okay, so going back to our script here, I'm going to set, and this is happening once per frame, so I'm updating every frame, potentially updating the rigid body that is associated with the game object that this script is attached to. I'm updating that rigid body's velocity. What's its new velocity going to be? It's going to be a vector 3. Now this float h, this is the current value on the horizontal. If I don't do a negative h here, it'll actually move in the opposite direction than when I pressed. It's just how their horizontal axis is represented. So if I take that negative h off here, and I go back out here and I hit play, and I hit left, he moves right. If I hit right, he moves left. So that's why we have the negative in front of it. It's just because of how the values work. The -1 is on the opposite side, and if we're using that as a scalar, notice that we're using the value associated with that horizontal axis, whatever that is, some value between -1 and 1, we're using that to multiply it by a move force. What's that move force? It was a hard-coded value that we invented up here. So we just decided it was 10. If we made it higher than that, he would move faster. If we made it slower than that, he would move slower. Make sense? So that's just our value. So, and this is the X coordinate, this is the Y, this is the Z. So he's not moving up and down, and he's not moving in and out. He's just moving side to side on the X. So the only thing we're doing anything with is we're applying a velocity to his X coordinate, and we're applying the current position on horizontal, inversed because of the way the math works, times whatever that move force is. Make sense? And we're applying that to the rigid body. All right, if I make this guy 50, you'll see that he'll move more quickly. All right, makes sense? Now, one thing we can do is if I come up here and I change this variable to be public, instead of move force being a private variable, I make it a public variable. And this is a kind of an important part of how, did we talk about MVC in here? Have I mentioned MVC? Okay. All right, so for any of you who've had other classes with me where we talked about this, what is MVC? Nobody's had another class?
It's like the code and like the interface like separate, but then like how they work together give you that.
Okay. So let me give you one additional slide. That's pretty much correct. We'll add some more stuff. So we have this concept called a design pattern. And this is not a game programming concept. This is let's call it a software development concept, but it really is a concept of everything, just even real life. So the design pattern is a proposed good solution to a common problem. That's what a design pattern is. So now it depends on now you got to decide, well, what does it mean for a solution to be good and what does it mean for a solution to be common? Right? Those are two separate things. If you're a rocket scientist, a common solution might be for you, a common problem for you might be something with like, fuel efficiency on rockets or something like that, where that's certainly not something that's going to be all that interesting to an accountant. So a common problem is kind of in the eye of the beholder. Similarly, a good solution. So the example I typically use with design patterns is, making a peanut butter and jelly. So this could exist in real life, right? So, there's different people think they have a different approach to making a peanut butter and jelly. Whether you put the peanut butter on, like, okay, what's your approach? Who thinks they have a good way of making a peanut butter and jelly so you don't rip the bread and that kind of stuff? We have an approach. How do you make a peanut butter and jelly?
Peanut butter, pickles, and cheese.
Peanut butter, pickles. Oh, let's go with that one.
Just get the bread up, put the peanut butter down.
Tell me about that putting the peanut butter on part. How you doing that?
Descriptive or just like generic?
Well, just with special approach.
Get a butter knife out, put it into the jar, spin it around, pull it out, and then slip it across the bread.
Okay, but so you got to be a little gentle when you're taking it across the bread, because if you push too hard, you might rip the bread because the peanut butter is a little thicker, right? So there's kind of an approach to it, right? Anybody else have a different? So peanut butter, pickle, and cheese. It's interesting. Sounds like it could be good. It's kind of surprising how pickle goes well with things you wouldn't have expected it to go well with. But, anybody have another approach to peanut butter and jelly? Because I do. Because it's kind of dangerous, I think, to spread it with a knife. So what I do is I kind of take little, like almost globs of peanut butter, and I just so gently just get it off the knife onto the bread, and then I kind of dump some jelly somewhere in there, and then what I do is I smash it together, and that kind of spreads it all out. Plus then the sandwich gets bigger because and then everything's more evenly distributed throughout the thing and stuff like that. But point is that, obviously in this particular case, my approach is better. Okay, because he's making a different sandwich. Yeah, but in any case, what does it mean for a solution to be a good solution, right? So you can come up with other examples in real life where people think they have a good approach to something that somebody else might have a different approach to. So that's all a design pattern says. Here's a proposed good solution to a problem. Okay, so it's a very, very, very generic type of concept. One of the design patterns that exists in computer science is this design pattern called MVC. Now, something else I typically say when I introduce design patterns is that academics love design patterns. You heard this concept called publish or perish before? So academics have to publish papers and stuff like that. And part of publishing papers means that we have to go and identify, new areas of research and stuff like that in your field. And, sometimes it's hard to find a little niche where design patterns are perfect. Because one of the rules of a design pattern is it has to have a funky name. And a common problem can be almost anything, right? And a proposed good solution doesn't always have to be the best solution. So you can literally come up with a crazy name for a problem that maybe is only important to you and 3 other people on the planet. Propose a solution that, let's say, it probably needs to be a solution, but it doesn't necessarily have to be good, just a solution. And now you've moved the area of research forward. Somebody else can come along and look at your paper and say, okay, well, here's an even better solution than that. And then they get a publication out of it. And goes back and forth, blah, blah, blah. Okay, so Model View Controller, or MVC, stands for Model View Controller. That's what this guy stands for. What does it mean? It says it's a good idea to separate your logic from your interface, and then also technically from your data, even though we're not working with a database yet. Okay, so you have these different components that go into a software project. So you have what your project looks like, so the interface. Then you have the logic, how it works. And then you have maybe a database that remembers stuff between runs of your application, something like that. All right, so MVC says it's a good idea to keep those in separate places so they don't get all mingled together. All right, and MVC was really born out of a problem that used to exist with a language called PHP, which is a language for doing dynamic web programming. And in the early days of PHP, what you would have is you would have a single file like index.php, and inside this file you would have HTML and PHP code intermixed. Now, when the websites were pretty simple in the early days of the internet, this wasn't a big deal. But as your websites got bigger and bigger and bigger and bigger, these files got pretty scary. They got thousands and thousands of lines of code where your logic is now twisted inside of an interface because the HTML is what kind of paints your picture for your website. So what did they say? They said, oh, well, MVC is going to say we're going to separate those two. PHP code lives here, HTML code lives here, and your HTML code will load that PHP code. And that's how they've connected. So MVC has more to do with how. MVC is not an implementation. MVC is an idea. It's saying it's a good idea to do that, to separate those things. Now you have to rely on how is that implemented on different platforms. Okay, we're going to look at Unity's implementation of this in a second. But they're basically saying, okay, your interface lives here. Your logic lives here. How do we connect these? That's MVC. How do we get those guys to talk to each other because we've made that decision to implement them in separate places? That make sense? All right, so we go back here. I made this guy public. So this is my logic, right? This is the code that makes my program run. Okay, so this is my logic. And I happen to make this guy public right here. Now, when I go into the Unity editor, that's my interface. This is my interface over here. Now, when I click on the golem, you're going to notice down here for golem movement, that move force is now in here. So I've exposed that variable to the interface so I can come in here and I can switch it back to 10 in here. So I can give it a default value, but then I can tweak the movement speed through my interface here rather than constantly having to go back and change the code. for things where that might make some sense. All right, so I'll make it back to a 10. All right, so make sense? All right, so now, next thing we need to do is, because he's falling over and stuff like that for our golem, we need to do some more stuff with freezing his rotation. We froze his rotation on X. Why did we freeze his rotation on X before?
You like rolled down right away.
Yeah, so he's standing on a slope, right? So his X is the bar going across him. So his rotation on that, if you're kind of hanging on this bar, would be your front and back rotation. Your let's see, your Z rotation would be left and right, which seems to be what we want to do here. And then your Y rotation is the bar going straight up. So that's going to be your kind of twisting rotation. So we want to lock him on the Z. All right, so now we see his Y is still twisting. So we're seeing the Y. Oh, that actually kind of, he sees yeah, look at that. It's a better game this way. All right, so we're seeing those individual axes he's rotating about as we lock each one down. All right, so Y is a bar that's going up and down through his body. So his rotation about that bar is the rotation on Y. The rotation on Z is a bar that's going from me through his body into the screen on that axis. So his rotation about that is going to be, this one, the one where we saw him falling over. And his rotation on X is a bar going left and right through his body. So that's where he would lean forward too far or fall back too far. So if we finally, if I can test it here, I can go ahead and freeze the rotation on Y. Notice he's not rotating anymore. He's stuck in his current rotation. He was half rotated, so he's stuck there. He's not rotating, so I'm stopping there and he's not continuing to fly. So, but notice, watch this Y right here. When I turn the game off, that became unchecked. So I think I reminded you this one other time, but when you make changes in real time like that, they don't stick. It's like a quick little test to see, will this fix the problem? So now if I want it to stick, I'll go ahead and freeze the rotation on all the axes. And now he only moves back and forth. All right, make sense? Okay. So let's go back into, nope, that's not it. We are, I'll probably bump this forward here a little.
If we go here, the first thing that you're going to notice when we run our game, I'm going to turn off the pumpkin just for a second. The first thing that you're going to notice when we run the game is that our, golem is going to fall down.
Okay, so we've seen all that.
Go into the rigid body of the golem and
Really dislike this.
You saw the consequences of him being.
Just have to jump forward this way a little.
Working for a moment ago. It's right here. Let's simply set here negative H and everything will work correct.
So we've talked about that stuff.
Column is moving the camera's position.
What's happening? Good there. Okay. I think this will be a decent place to start. All right, so now what he's doing, so we have our guy moving back and forth, and we had our single pumpkin up there that was kind of our starting point. Now he wants to create positions where our pumpkins might spawn, okay? Because the idea here is that we're going to have a bunch of pumpkins across the top here. There's the ability to have pumpkins drop across the top here. So if a pumpkin fell out of the sky right here, it would roll down this path here. If it fell over here, would roll down this path here. So we want pumpkins kind of randomly dropping across the top there, so our dude can, it's a video game, and our dude can go and dodge those pumpkins and stuff like that. All right, so, some different things we can do is we can decide, well, we're just going to have a range, and this could actually be maybe even a more granular way of doing this. You could say, well, this is the farthest, so this is our X and Y position, right? Actually, this is going to be a depth of Z to get us here. And then an X, and actually it'll probably be a depth of Z and a elevation of Y, since it's actually above us. So we're going out, then we're going up a little bit. That puts us at the top of the ramp. And then we're going to say, here is a range of X's that kind of cover the width of the ramp up there. And we can say, we're just going to randomly pick an X, and that's where we'll drop a pumpkin. Then we'll randomly pick another X, and that's where we'll drop a pumpkin, so on and so forth. So we could just deal with a range like that and make it, let's say, completely random. So you may not even have two pumpkins that drop in the same place. They might drop in a pretty similar space, but they won't drop in the same place. So we can do that writing complete logic for generating a random number between those minimum and maximum X ranges. Okay? Now, the way he's going to do it, he's going to pick spawn points. So he's going to pick 5 or 6 spots. He's going to say, okay, well, maybe this is a good spot here, and this is a good spot here, and this is a good spot here, so on and so forth. And he's going to drop empty game objects there, as our potential spawn points. And that way, what he can do is he can pick a spawn point and have the exact vector 3 location of that spawn point as the place that we're going to spawn a pumpkin. And then he can pick another spawn point and get the exact vector 3 position where that guy lives. So you have a lot more precise control over exactly where something shows up. All right, and so this is going to be a good use of empty game objects, where it's something we don't physically see on the screen, but it's still representing something in spatial space. All right, so that's where he's kind of going with this.
So like this background, just a color palette, and I can set it to this color, a little bit darkish. You see, because this is a scary.
So real quick here, he's clicking on main camera, and we have this background color. He selected it, and I think we need to change the skybox to a solid color. Then we can choose this guy to be dark, so I can see the camera preview there down here. And now it's dark. So now our game looks a lot more terrifying. You see that pumpkin on turbo speed there?
Game. This is a horror game. So this is, for changing the colors of our background. And don't worry, all of this we will talk about in the course. We will see what our skybox is, how can we create mood, and all of the good stuff. Now, what we need to do next is create a spawner. And this spawner is actually just going to be an empty game object. So I'm going to right-click, create empty, and position it at 0, 0, 0. And I'm going to tag in here with this tag and rename it to spawner like this. And this is where he is. So he is in the middle. And he's going to have child game objects. So here I'm going to select or right-click on the spawner, create empty, and this game object is now a child under that game object. And we will talk about children and what our child game objects are and so forth.
All right, so what he's doing here is he's going to create a collection of game object. This is just an organization thing, right? So we're going to create an empty thing, right? So we're going to create an empty game object here, and he called this guy spawner. So I'll just click on that guy to get it to highlight, and we'll call it spawner. Now I'm going to go ahead and I think I'll double click on the pumpkin. This gets me to roughly where I want to be. I'm going to go ahead and remove the pumpkin from the scene. I just disabled it up here so I don't see it. And I'm going to use that to position my spawner. So what I'm actually going to do to start with is I'm going to go up to pumpkin, and I'm going to click on the little gear here under transform. And I'm going to say copy component. Then I'll click on my spawner and click on that gear by the transform and say paste component values. And that just moved my spawner into that rough location so I can operate off of that. All right. So now what I'll do is I'm going to create, let's see, what did he name his? Oh, he didn't name them yet. But we're going to right click here. We're going to create an empty game object inside of spawner. Okay, and we're going to call this guy P1, kind of for point 1. And what I'll do is I'll just drag this dude to some spaces off of spawner there. Now, one thing that he did is for P1, he went and he didn't tag it. There's a way to give a flag to it. That's not it. Here, yeah. So you click on this little box up here, and you can kind of give it like a little flag so you can sort of see it on the screen. So notice when I selected that, it showed up. So this won't show up in the game. This is just visual for me to be able to lay stuff out. Okay, so now I can see where that point was. And I'm going to go ahead, I'm just going to guess he's doing 6 points. So I'm going to copy this guy, make 6 points here, and I'll drag them-ish away from each other. All right, and as you can see, they are perfectly equidistant from each other. So I roughly laid them out. So I have some different points there, and I'll go ahead and rename them just for the sake of completeness. So I'll call this guy P2. We'll call this guy P3. P4. P5. And P6. All right, so we have some spawn points there that where we might want our pumpkins to live. All right, so now we're going to have a pumpkin spawner, and he's going to end up, I believe, he's going to end up attaching this to our spawner object here. So I'll just talk ahead, and then we'll go and look at what he does. But he's going to create a script for spawning pumpkins. I think he's probably going to attach it to spawner, but he's just going to attach it to some game object in the scene. Doesn't really matter what it is. And he's going to associate our prefab, that is our pumpkin, with that guy so we can create instances of that pumpkin. And then he's also going to associate, he's going to have a probably an array of vector 3s that are going to associate our 6 spawn points here. And then we'll be able to drag our 6 spawn points in, and then logically we'll randomize a number between 0 and 5, picking a spawn point maybe every 20 seconds, something like that. Maybe it's probably less than that. Maybe every 4 seconds there'll be a new pumpkin that gets spawned. Maybe even be a range every 1 to 4 seconds. There'll be a pumpkin that spawns, and it'll spawn at a randomly selected location where we'll use the position on one of these vector 3s. All right, so that'll give ourselves the illusion of something kind of randomly happening. Okay, so we'll go back here.
But essentially, child game object.
So I'm gonna let me show you one other thing here before we go any farther. If I click on spawner and I move this guy, notice that all the objects underneath him move with him. So that's kind of a advantage of nesting game objects under other game objects. We can move them as a group. Okay.
Okay, simple as that. I'm going to click on this icon right here and give him, let's say, and set his X position at 10.
So he's giving you some real specific layout positions.
20. Here is where we want our spawner kids.
Okay, so notice he did create a script and he's associating it with, I'm assuming he's going to associate with our spawner. So we created a script here called our spawner script.
What's going on? This is just a
so let's go ahead and let's create that script. So we'll go back in here under my assets and then scripts folder. I'm going to right click. We're going to say create C# script. We'll call this guy spawner. And then I'm going to go ahead and presume he's going to attach it to our spawner here. It wouldn't make a whole lot of sense to do that. So I'll drag him onto our spawner game object. Really, the way we're going to write this, it just has to be on one of the game objects that's in our scene. That way, because if it's sitting in here, it will never start. It won't create or anything. It's just an untapped resource until we actually attach it to a game object that lives in our scene. Okay, so we have this spawner script. I'll go ahead and open that guy up. All right, and let's see if he does make that collection of our
master game so that we can see how easy it is in a couple of lines of code to create a game. Drag and drop it on the spawner game object himself. Because all of this, what we're doing, will be explained in how.
I'm going to jump forward a little bit here.
Or arrays, so arrays like this, and these are going to be our spawn points.
All right, so he's making a transform array. So instead of a vector 3 array, he's making a transform array. A transform, let's go ahead and add that to our notes. Now that we're thinking about it from the perspective of a data structure. So if you were to define a transform up to this point, what would you say a transform is? Based on what we know. Every game object has one. What does that imply about every game object? They have a what?
Position.
Position. Two more things. Rotation.
And like size.
Scale. Yep. Those 3 things. Position, rotation, scale. So transform is a collection of those 3 things, and each of those 3 things has 3 variables inside of it. So what's a transform? It's a collection of 3 vector 3s. All right, so from a game, from a programming perspective, a transform is a collection of 3 vector 3s. One for position, one for rotation, and one for scale. That make sense? So what he's doing here, and here we'll just throw this in here since I know some of you are in one of the earlier programming classes. He's creating something called an array, which we haven't talked about in 250 yet, but an array is like a Python list. Okay, so it's a collection of like elements. All right, so the way we're going to make, he's going to create a transform array, which is going to be a collection of transforms. That's the kinds of values that will live in there. All right, so if we go back here, you see that he's making, let's look at his screen here. We'll still try to look at his screen here. I'm just going to try to do it at a significantly more competent level, like that. Okay, notice he's making a transform array here. So this is how you define an array, open and close square brackets. So for those of you who are in the Java class, you're going to see this pretty soon. This is how we'll make arrays. Okay, he's calling it spawn points. Now, he made it public. What will that do?
Like a thing you need to mess with.
Yeah, this is MVC. The second he made that guy public, he's exposing that variable to Unity. All right, so I'm just going to do up to this point here. So I'm going to say, we're going to go in here, we're going to make, in our spawner class, I'm going to make a public variable, which will expose it to Unity. It's going to be of type transform array, and whatever you call it. I'm going to call it spawn points. I think that's pretty close to what he called it. All right, so now I have a public transform array spawn points. Now what we'll see here is if I go back over to Unity, we click on spawner. See, the script here has this thing called spawn points, and the first thing it wants to know is what's the size of it. So it lets us define it. Now in my particular example, I have 6 spawn points. I think he only had 5. So I'm going to say, okay, I have 6 spawn points here. All right, now notice it's now giving me 6 little buckets to drop transforms onto. And since a game object is by definition a transform, that's what we said is the minimum game object is a transform, I'm going to drop P1 into the first one, P2 into the second one. This goes back to why I said it was a good idea to have your hierarchy over here on the right, so it's nice and close to where you might be dropping stuff in. P3 into the next one. P4, P5, and P6. Okay, so now I've associated those 6 game objects with my script. Now I could have gone into my script, you go back here, and I could have created 6 different public game objects here, or 6 different public transforms. Maybe public transform P1. Public transform P2, public transform P3, and then had 6 different containers for it to drop into, effectively giving me the same thing. But I chose to make it an array. Why do you think I made this an array? What are the advantages of making this guy an array based on what you know up to this point? So kind of a problem-solving approach that I'm taking here. First of all, we saw with our array that we can have a flexible size, right? Could I change that to 14 spawn points in not too much time over in the Unity side and then just create some more game objects in there and drag them in? Real easily, right? So it makes my script pretty flexible to accomplish different things. Now, given this whole, when we think about a video game, is the idea of randomizing spawn points for things maybe somewhat of a common task? Whether you have your Mario guys or whatever. I think if you go back to some of those older games, I think these guys started at very specific places just because of the way the games were built back then. But generally speaking, games today, you want to have some randomness to it. Otherwise, it'll feel kind of boring. Like, okay, this dude always starts in this place, so I can avoid him by just doing this, that, or the next thing, right? So you want the games to feel a little bit more human or less predictable. So the idea of having random spawn points or a whole bunch of places where things could spawn, but you don't necessarily know where they will spawn, is a common component of many games. So this little script we're writing here really could be repurposed for a lot of different games if we let it operate on a collection of spawn points where we get to control how many spawn points. Maybe some simple games only have 2 spawn points. Maybe really complex games have 1,000 spawn points where things could possibly happen, which would suck to be the one who has to drag 1,000 game objects in there, but that's what interns are for. So in any case, that adds some flexibility here. The other thing it's going to do for us is, because I've kind of mentioned that the way we're going to handle these spawn points is by having, we're going to kind of select a random value, in this case between 0 and 5, because the arrays are 0 index, just like lists are in Python, just like arrays are in Java, C#, well, this is C#, Objective-C, all of them. All right, so we're going to pick a value between 0 and, in our case here, 5, the length of the array minus 1. And that's going to give us one of those spawn points. We'll just pick a random number in there, and that's where we're going to create a pumpkin and have it plop down in that spot, and then he'll start rolling naturally once gravity kicks in. That make sense? All right, so having the array allows us to just pick a number between 0 and the length of the array minus 1, and then have logic associated with that, rather than us having a whole bunch of these public transform variables at the top here. And if you want to have 5 more, you have to add 5 more variables, that kind of thing. So this makes it very flexible for us, even though there are more than there's more than this way to do it. Okay, so he created a spawn point array. He's also going to create a public game object. I'm going to call it the pumpkin. All right, and this is going to be for our pumpkin prefab. If you remember, so here's it'll pop up here in a second. There's our pumpkin for our game object there. Go back to assets, go to prefabs. Remember we created this pumpkin here that is the look of our awesome pumpkin? That's our awesome pumpkin we built. So I'm going to get that opened over here under prefabs. I'm going to click on spawner again, so I'm on the right place. And I'm going to go ahead and drag that pumpkin prefab into there. All right. So now I have kind of a blueprint for generating pumpkins that I've now associated with my script. So then I can create instances of those guys on the fly. I could say, poof, make a pumpkin. Poof, make another pumpkin. So on and so forth. Make some sense? Okay, so let's let him catch up a little bit here. Let's go to right there and see where his code is at this point. Yeah, so there's our public game object pumpkin. He's getting ready to create this I enumerator thing he's getting ready to create is going to be for something that he can call on a timer. So we'll let him go a little bit quicker. So this is going to allow it to have a, I'm not sure if he's going to do it on a constant beat or a random beat, but the idea would be that, I mentioned a few minutes ago, maybe every 2 seconds a pumpkin comes out, or maybe every 1 to 4 seconds a pumpkin comes out. You can make these guys, you'll see how the function is formatted. So there's our start spawning. Yeah, he's doing a random range for it. So we'll just let that cook a little farther. All right, let's just stop it right there. That's a good place for us to see what's going on. So he's creating this thing called start spawning. Now, this isn't being called yet. You're going to see how he calls it here shortly. But it has to return something called an I enumerator. That's just the type of object it has to return that works with Unity's timing system. And he's going to call it start spawning. All right, so let's go ahead and start writing that piece. So we're just going to create enumerator. Now, if you noticed, he starts his functions pretty commonly with a capital letter. There's nothing wrong with that, but historically good programming practice is function names start with a lowercase letter, class names start with an uppercase letter. It's not a deal breaker, just more of a style difference. I think this goes a little bit against the norm for historic programming. Maybe in the game programming field, because it's a younger field, they've taken a different tack to that, but whatever, just for your own information. All right, so the very first thing he's going to do in here is he has this yield line, which is going to say wait for some amount of time. Okay, so this is actually kind of a call to a function in and of itself. So he's saying yield return, then he's going to say new wait for seconds, random range 1f to 3.5f. All right. So very first line in here, we're going to do some yielding. Then we're going to return a new wait for seconds. I don't know why that didn't pop up. And then he did, what was it, 1.5f to 3.5f? Or was it 1f? Doesn't matter. Doesn't matter. We'll just leave it. Oh, I need to do this inside of random range. Sorry. Yeah, see, these guys should have highlighted in blue, wait for seconds and random.range. Did not show up like that on here, but it also doesn't see an error. One thing I'm going to do here real quick is I'm going to close. This happens sometimes. I'm going to close this. I'm going to save this. Go back into Unity. It would have still worked as it was there, but it's going to be more convenient if it's doing command completion for us. So I'll open up Spawner again, and let's see if it looks a little bit better this time around. Yeah, so they're highlighted now. Sometimes it loses the Unity engine stuff. Won't command complete it. All right, so we're gonna yield. So we're waiting for this. What are we waiting for it to do? Return the result of waiting for some number of seconds. How many seconds? Well, random range 1.5f to 3.5f. All right, so this function will wait for between 1.5 and 3.5 seconds. All right, and then what is he going to do? He's going to instantiate something. So he's going to instantiate our pumpkin. So remember, this was kind of our blueprint for our pumpkin prefab. So we're going to instantiate a pumpkin. And then it wants to know, where are we instantiating it? So we're going to take our array of spawn points, this guy right here, and we're going to pick a spot between 0 and spawn points.length. Now, random range will give us a value that's below that second one. So 0 to spawn points.length will give us a number between 0 and length minus 1. And then we're going to say, give me the position of that particular transform. That's the place that I want to instantiate this pumpkin. All right, so that's where. The last variable here is the rotation of it. All right, so notice it doesn't take a scale. It says I'm going to instantiate this prefab at, so instantiate what, where, and with what rotation. So let's go into our slide set here. So instantiate, creates a new instance of a prefab, and it takes 3 parameters. What we want to instantiate, where we want to put it in the scene, what rotation does it start at? All right, those are the 3 pieces of information we need to instantiate something and get it into our scene. All right, so he's calling instantiate. So there's our instantiate, open parenthesis. Okay, so notice that there's 10 versions of instantiate, but the one we're looking at here is the most common. So one version is here's the object we're going to create. There is the object with the full transform, and a transform has 3 different vector 3s, right? Here's another one where it takes the full transform as well as a true or false instantiate in world space, as opposed to the space governed by whatever parent it might be instantiated within. Okay, here's the one we're going to use, which is the original object, the vector 3 position, and then the quaternion rotation. Okay, so let's look at that here real quick. Quaternion. Am I spelling that right? Quaternion. Yep, looks like it. All right, so quaternion. Fancy math term for the rotation. Okay, now it really is fancy math. So quaternion mathematics is difficult math. So one of the nice things we have for us with Unity is it will do quaternion math for us, so we don't have to worry about it. So the skill set we will have to come up with is how do we manipulate rotation in terms of quaternions to make it work. We're not just dealing with degrees. Make some high level amount of sense there. All right, but whenever you see the word quaternion, we're talking rotation. Those are synonyms for us. All right, so we're going to instantiate. What are we instantiating? This dot the pumpkin. That's what we're instantiating. Where are we going to instantiate? Now, rather than me put it all in this line right here, I'm going to go ahead and I'm going to create a vector 3. I'm going to call it temp. Not necessary. I'm just kind of splitting the one line into 2 just so we can kind of see here's where I'm picking my random position. In fact, actually, I'm going to do it in 3 steps. So I'm going to say int pos is equal to random dot range, and I'm going to go from 0 to this dot spawn points dot length. Okay, this guy right here, this will generate a random int between 0 and length minus 1. That's what that line will do for me. Okay, now I want to use that position to grab a vector 3 from my spawn points. So vector 3, we'll call this guy vpos, and this is going to be this dot spawn points at bucket pos, which is the position we just randomly generated, dot position. Because those guys that's a collection of transforms up here. I want the position, the vector 3 position associated with the transform that lives that position pos inside of spawn points. Make sense? So now I have that vector 3 right here. And that's the position where I'm going to put my pumpkin that I'm spawning here. All right. Lastly, it wants a quaternion rotation. And I'm going to say I want default rotation, just 0, 0, 0 across the board. So we have something called a quaternion dot identity. How many of you have had a linear algebra class, either high school? Well, do they do linear algebra in high school? Maybe not. How many of you had a linear algebra class in college so far? What math classes have you had?
Algebra, calculus, discrete math.
Okay. Discrete math, do you do anything with matrices?
We're not. I'm taking it now.
Okay. Gotcha. All right. So, yeah, so this an identity matrix. Typically, it's in a linear algebra class, but they might put it in discrete math as one of the chapters or something like that. This is a matrix that is filled up with zeros. So in our case, a vector 3 is, if we think about it in rows and columns, is a 3-row by 1-column matrix with zeros throughout for X, Y, and Z. And that's what quaternion identity, quaternion identity says there's zeros throughout that matrix. All right. And that is kind of like our, we could almost think about it like multiplying by 1 when we're doing normal multiplication. It's something that is used as a base case for when you have matrices multiplied together to not change the original, something along those lines. All right, so we're going to instantiate this dude at this position with no special rotation, just default rotation. Okay. Now, when I say default rotation, that is going to be default rotation for whatever that prefab was. So if your prefab had a funky rotation on it, that's what that rotation is what it will have when it comes in here. We're not doing anything special to it. All right. So that's what we're going to do when and if this function is ever called. All right. So now notice here inside of start, I'm going to kind of connect the two here. I know he has an extra line here, but we'll come to it. Notice inside of start, the very first thing he does is he starts something called a coroutine. All right. So let's talk about coroutines here for a second. So this is a function, I'm going to say, that must return an I enumerator that is called within its own thread of execution. Okay, what does that mean when I say something's called within its own thread? We heard of multi-threading before? Do we know what that actually means, or is it just a funky phrase? I love how lively everyone is early in the morning. You don't all get up at 5 in the morning and run. I usually do 6, 7 miles before I even come in here. Stanton, you're actually a really good actor because you look like you actually believed me. Like, you do not look like a guy who runs 6 or 7 miles. Maybe you drove 6 or 7 miles here, which is true. So what is it? What's multi-threading mean? As opposed to when you take the systems programming course, we talk about this stuff. Multi-threading versus multi-processing. So multi-processing says that more than one thing is happening at once, right? Because we have a process, a program that is running at the same time as another program. Now, that could actually legitimately happen in today's hardware because we have multi-core processors. So we can have, in a quad-core processor, we can have up to 4 physical things happening at once. One of the things we look at in 450 is that processes are big. They're heavyweight things, and if we want to have something running in a separate process, it takes a lot of extra data to do that. So we have this thing called a thread, which is a lightweight process, kind of a mini process. And it allows us to schedule things, and just to keep things simple, I'm going to say as if you have multiple things running at the same time. Realistically speaking, with multi-core processors, multiple things could be running at the same time. Okay, but the real thing here that we're looking for is running in its own thread means it does not block. Okay, it means that see, this is really funny because when I'm done recording, this guy always shows me all of the things that, oh, this is what you missed while you were screen sharing. What about the things I didn't miss while I was screen sharing that you just popped up for me? Whatever. Let's wait for me just to keep those to make them shut up. Let's go with this. So running on its own thread means it does not block. So then what does a blocking call mean? So blocking calls prevent the logic that follows from executing until the call has completed. All right, so non-blocking calls say, I want this thing to kind of go and do its thing, happen, go, but don't prevent me from doing some other stuff. Threads allow us to do that. All right, so threads of execution allow me to say, okay, I'm in the main thread right now, my normal game, let's just say, I'm oversimplifying, but I'm in my normal game, my normal thread, I'm writing my logic. Now I want something else to happen at the same time. All right, that's what a coroutine is used for. All right, allows me to create this other thing that kind of happens on its own time schedule. Otherwise, my ability to do things currently is happening inside of that once per frame pump called update, where I can say, here's the 30 things I want to happen in this order in update. And if I have one thing in there that blocks for some period of time, let's just say I randomly put a for loop that counts from 1 to a billion inside of update, and I just happen to have it print out in there. That'll take enough time because printing is expensive. When it prints out to the screen, something that you wouldn't necessarily need for a video game, right? But when you print to the screen, that's a very expensive thing. You'll learn about that in the operating system class. It's called context switching. It's expensive. So if you have a for loop that runs through a billion times and it prints each time through, I guarantee that it'll take a lot more time than one frame. So what you're going to end up happening is you're going to have only part of the logic of that particular update happen because it'll get killed off when the next frame comes in. So we need to be somewhat careful what we do inside of update to make sure that it could occur within a frame. That makes sense? You don't want to do a bunch of crazy stuff in there. If you need to have something very logic intensive or time intensive happen on the side, you throw that into a coroutine. Okay? All right, so start coroutine. Well, up here, he's going to start a coroutine. What coroutine? This one called start spawning, which is this dude down here. What does this guy do? It waits for some amount of time. Then it creates a pumpkin. Then it calls itself. Okay, so what do we call a function that calls itself from within itself? What kind of function is that? Yeah, it's a recursive function. So this is recursion. this is somewhat fake recursion because we're actually calling start spawning, not directly, but through the start coroutine function, but it's roughly recursion. Okay, what does this guy do? We get the ball rolling in start. This happens exactly one time. So we start the coroutine, start spawning, waits, creates, initializes, starts the coroutine again, which then says wait. There is a version of start coroutine called start coroutine repeating, which you can just allow it to say, well, every 4 seconds I want something to happen, or every however, I just want this to keep pumping. All right, but in this, it allows it, by doing it this way, it allows us to potentially put some logic in here that maybe says, if there's more than 3 pumpkins currently alive, just skip this. Okay, don't make another one. We have enough. All right, make some sense? So we'll go ahead and call our start coroutine in here. So start coroutine, the name of our coroutine is start spawning. Oh, I didn't put the open closing parentheses on that. I'll do the same thing here. Save that. And then I'll come into my Unity, and that's already attached to our spawner. I'll go ahead and hit play. There's our first pumpkin. It's rolling. Now 1.5 to 3 seconds, we see another pumpkin that just appeared. Another one. Man, our guy's a little fat. He blocks. Oh, bad luck. It actually was kind of cool look. All right, so we have pumpkins that are spawning now. All right, so for Thursday, bring your game up to date with this and go ahead and submit a screenshot, that is something in the ballpark of what I'm looking at here with maybe 2 or 3 pumpkins on the screen kind of showing that happened. All right. And then also submit your spawner script. Those 2 things, a picture and then the script that we wrote called spawner. Cool. All right. Questions, comments, concerns, bribes? Bribe?
Question, do you want us to do a self-assessment on that too?
Yes, yeah, I put that up just the other day, so I'll announce it at all my classes. But yeah, do the self-assessment. This one shouldn't be too bad, but as we move forward, get used to doing that. Okay, as usual, you're invited to come sit in the front row with me at chapel. Lots and lots and lots of room up there. All right, also today, student, faculty, staff Bible study, God and Grub at 1 o'clock it's noon to 1. Just go to the cafeteria, sign in, you get a free lunch, take your tray down to the terrace room, and Pastor Smith runs a Bible study. I'll be there. The seat will be waiting for you. Go ahead.
How do you do the orange one?
Yeah, so once you selected one of these dudes, here, I'll just show you this. You select like the spawner. If you click on this box up here, it lets you choose like a dude associated with it.
What if I did that and it doesn't pop up?
You did that, but it doesn't pop up. I guess do it better.
Okay.
Make sure you've actually selected something. If you don't see it, here's my real answer to this. If you don't see it, it's possible that your thing is actually below the floor.
So now I got it for you.
Okay. But that's something that actually happened to mine at the beginning here. I had it on the wrong Y. So they were there. I could see it kind of through the floor, but I had to elevate it up to get the pictures to pop through the floor. Okay? All right. I will see everybody on Thursday.